everybody, and welcome back to another video. In this video, I will be covering partial derivatives and second partial derivatives and how many a given function has given the number of inputs and the number of outputs. So in this case, we are just dealing with a function with one output, two inputs. So our function maps from R2 to R. So this is saying this is a function of x, y that outputs z. Now, let's first find the first partial derivatives of this function. So, since we have two variables, we have dz over dx, and we have dz over dy. So these are our two first partial derivatives. Now, let's find them. So what we mean when we say partial derivative is we're treating the other variable as if it was a constant. So since we are looking at a three-dimensional map in this picture, imagine looking at a cross-section of that where you treat y or x as constant and it's just x versus z. Essentially, we're finding the slope of that at a given value y that you sliced it. So for our first function, for our first case, let's take the partial derivative of this with respect to x. So first off, we differentiate that first term, so that just becomes 2x by the power rule. Now this, we don't have to do a product rule on, because this is a constant. Imagine this just says like 5, 6, 1. We are just going to leave it as if it was a constant. So this becomes 2x times y cubed. Now we are going to add the derivative of this with respect to x, which is just y squared, because this is a constant, or this is a constant with respect to x, so this just becomes 1 times y squared. So this is our first derivative with respect to x. Now let's do that for y. So this is equal to, so this term becomes 0. So this is 0 plus this term becomes 3x squared, because that's a constant, times y squared. Now we are adding 2xy. So this is just 0, so that's not really there. Now let's look at these functions. So we have an output of two variables, which are two inputs. So each one of these has their own set of two partial derivatives. So we can split this one up into dz over dy squared. Then we could split it up into dz, or this would be d squared z over dx dy, and this implies the partial derivative with respect to x of dz over dy. Now, and then this is just the same thing, but this implies d over dy of d over dy of z. Now let's do that for x. So this side becomes d squared z over dx, which is just d over dx of, this is over x squared, of dz over dx. And then we have this with respect to y, so this becomes d squared z over dy dx, and this is the partial derivative with respect to y of dz over dx. So as you can see, from this one function, we got 4 second partial derivative outputs. So let's solve for them. So let's take the partial derivative of this with respect to x. So we are going to write that d squared z over dx squared is equal to, now let's solve for it. So the derivative of this with respect to x is just going to be 2. Now that we are adding 2y cubed to, and because the x drops down, and then this just becomes 0. So I won't add the 0 at the end, but you know it's there. Now for our second one, let's find d squared z over dy dx. And that is equal to this function right here, so the partial derivative of this with respect to y. So this first term drops out, so that's 0. And then this second term becomes 6x times y squared, as this 3 dropped down, plus 2y. So this is our second partial derivative of z with over dy dx. Now let's go to this side. So d squared z over dx dy, which is different than this, so you cannot swap the order. This means something specifically, is equal to, now let's take the partial derivative of this with respect to x. So this just becomes 6x times y squared, as the 2 drops down, and then it's minus 1, it's just a power rule, plus 2y, as this just drops down. Now let's find d squared z over dy squared. And we are just going to take the derivative of this with respect to y now. So this just becomes 6x squared times y plus 2x. So these are our 4 partial derivatives for this function f of x comma y. So I hope you all enjoyed this video. I hope you learned a lot, and thank you for watching.